Welcome to Ajaxar Academy YouTube channel. In this session, I am going to discuss work, power, energy. In this, law of conservation of energy. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. Conservative force. Let us discuss. Work done by the force around a closed path is zero and it is independent of the path. Such a force is called conservative force. If force F is defined as F is equals to minus du by dx. Here work done by the force around a closed path is zero and it is independent of the path. Such a force is called a conservative force. So then the force is called a conservative force. Now let us discuss example. Gravitational force, elastic forces, electrostatic forces, magnetic forces, etc. So and all the central forces are conservative in nature. Non-conservative force. If work done by the force around a closed path is not equal to 0 and it depends on the path, such a force is called non-conservative force. Here force around a closed path is not equal to 0 and it depends on the path. So such a force is called non-conservative force. Example: frictional force, viscous force, air drag. Now we'll discuss law of conservation of mechanical energy. The total mechanical energy of a system is constant if the internal forces doing work on it are conservative and the external force do no work. So when a body undergoes a displacement delta x under the action of a conservative force F, then the change in kinetic energy of the body is given by work energy theorem as delta k is equals to fx delta x. So as the force is conservative, the change in potential energy, so that is minus delta u is equals to f of x into delta x. So therefore delta k is equals to minus delta u. So therefore delta k plus delta u is equals to 0. So delta of k plus u is equals to 0 or delta E is equals to 0. Kinetic energy plus potential energy. So therefore mechanical energy E is equals to constant. That is, if the kinetic energy of the body increases, its potential energy decreases by an equal amount and vice versa. Nothing but kinetic energy of the body increases, its potential energy decreases by an equal amount. Now let us discuss law of conservation of energy in a case of freely falling body. Now let us consider a ball of mass m is dropped from a building at a height h. So building height is h and a ball of mass m. Mass is m. The total mechanical energy of the ball is E. E is equals to Ke plus Pa, kinetic energy plus potential energy. So consider A, B and C are the points at heights h, h minus x and on the ground. At a point A, see here a ball is falling freely. It starts in rest, so that initial velocity is 0. When a body starts from rest, its initial velocity is equals to 0. So that is u is equals to 0. So at point A, the kinetic energy of the ball at point A is 0. So here u is equals to 0, then kinetic energy of mv square is equals to 0. So the potential energy of the ball at a height A, at a point A is potential energy is equals to mgh. Total energy at point A, that is sum of potential energy and kinetic energy. So mgh plus 0. So that is equals to mgh. Consider this equation number 1. Next, at point B, let us discuss. The ball reaches to point B. The velocity of the body at point B is Vb. The distance travelled by the body is x. The velocity at point B is, from the third equation of motion, v square minus u square is equals to 2as. Substituting v nothing but Vb, u is equals to 0. So Vb square is equals to 2gx. So kinetic energy at the point B is kinetic energy equal to half m Vb square. So substituting Vb square value in this, we get half m into 2gx. 2 gets cancels, mgx. So at point B, kinetic energy is equals to mgx. Potential energy equals to mgh. So here h is equals to h minus x. So potential energy is equals to mg of h minus x. So potential energy is equals to mgh minus mgx. Now we will calculate total energy. Potential energy plus kinetic energy. So mgh plus mgh minus mgx. mgx gets cancels. The remaining is total energy is equals to mgh. This equation considered as equation number 2. Next, at point C, when the body touches the ground at C with a velocity vc, kinetic energy equals to half m vc square. So from the third equation of motion, v square minus u square is equals to 2as. It becomes vc square minus u square is equals to 2gh. So vc square is equals to 2gh. Why? Because u is equals to 0. So kinetic energy at point C, that is half m into 2gh. 2 gets cancels. Kinetic energy is equals to mgh. Now potential energy equals to mgh. At point C, h is equals to 0. So potential energy equals to 0. So total energy is equals to sum of potential energy and kinetic energy. 0 plus mgh, that is equals to mgh. Total energy is equals to mgh. This is equation number 3. From equations 1, 2 and 3, at any point on the path of a freely falling body, the total energy is constant, that is mgh. So thus the law of conservation of energy is verified. Now I will discuss law of conservation of energy in a case of vertically projected body. A ball of mass m is projected vertically up from the ground with an initial velocity u from a point A. So this is the picture. Here a ball of mass m is projected vertically from the ground with an initial velocity u from this point A. Let A, B and C are the points on the ground at the height x and h respectively. At point A, as the height of the body is 0, the potential energy of the body is equal to 0. So PE is equals to mgh, that is equals to 0. So kinetic energy is equals to half m v square. Kinetic energy equals half m, v becomes u. So half m u square. Total energy is equals to potential energy plus kinetic energy. 0 plus half m u square. So total energy in the case of vertically projected body at point A is half m u square. Consider this as equation number 1. Next, at point B, the body reaches to a height x, then the velocity at point B is given by. Here the ball is projected vertically up to B, it reaches at a height x. The velocity at b is vb. So vb square minus u square is equals to minus 2gx. Vertically projecting a body. So a becomes minus g. Vb square is equal to u square minus 2gx. So kinetic energy is equals to half m Vb square. Now here Vb square substituting value half m into u square minus 2gx. So half m u square minus mgx. 2 gets cancelled. Potential energy equals to mgh. Therefore, since here h is equals to x. So potential energy is equals to mgx. Now total energy is equals to potential energy plus kinetic energy. That is mgx plus half mu square minus mgx. mgx gets cancels. So total energy in the case of vertically projected body at point B, that is equals to half mu square. Consider this as equation number 2. At point C, the ball reaches the maximum height position at maximum height. So at maximum height, final velocity is 0. Therefore, Vc is equals to 0. So kinetic energy is equals to half m Vc square. So kinetic energy is equals to 0. Potential energy is equals to mgh. H maximum is equals to u square by 2g. Potential energy is equals to mg into h. H nothing but maximum height to u square by 2z. So that is equals to half m u square. Gg gets cancels. Total energy is equals to potential energy plus kinetic energy. So total energy is equals to half m u square plus 0. So total energy is equals to half m u square. That is equation number 3. From equations 1, 2 and 3, at any point on the path of a vertically projected body, total energy is constant. So thus, the law of conservation of energy is verified. Now I will discuss MCQs. The total work done on a particle is equal to change its kinetic energy only if the forces acting on it are conservative, only if gravitational force alone acts on it, only if elastic force alone acts on it, for any kind of force acting on it. So here, for any kind of force acting on it. The work done by all the forces, external, internal, on a system equals the change in total energy, kinetic energy, potential energy, none of this. Here, kinetic energy. The work done by all the forces on a system equals the change in kinetic energy. Next we will discuss power. Power, nothing but the rate of doing work is called power. If W is the total work done by a force in a time interval T, then average power is P average is equals to total work by total time. So that is P average is equals to W by T. So the rate of doing work is called power. Instantaneous power is the dot product of force and velocity of the body. So provided the force does not change with the time. So the instantaneous power is P instant is equals to F bar dot V bar, that is equals to FV cos theta. Now if the work done is constant, then P is inversely proportional to T. So therefore power is a scalar quantity. Now I will discuss the units. CGS unit is erg per second, SI unit is joule per second or watt. So practical units of power is horsepower. 1 horsepower is equal to 746 watts. The electrical units used to measure the consumption of electricity is kilowatt hour. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. Now we will discuss relation between average power and instantaneous power. A particle starts from rest and moving with uniform acceleration gains a velocity v in time t. So P average is equals to W by T. So that is equals to half m square by T. So that is equals to half m into V by T into V. We know that V is equals to U plus AT. So V is equals to AT. A is equals to V by T. P average is equals to M A bar dot V bar by 2. So that is F bar dot V bar by 2. P average is equals to half P instantaneous. So since P instantaneous, that is instantaneous power is equals to F bar dot V bar. So note P instantaneous is equals to 2P average, taking cross multiplication. So instantaneous power is equals to twice the average power. Now we will discuss efficiency of crane or motor. The ratio of output power to the input power is called efficiency. So eta is equals to, this is symbol eta, eta is equals to output power by input power into 100. That is P naught by Pi into 100. So efficiency can also be defined as the ratio of useful work done to total energy spent. So if eta is the efficiency of motor, then total input power Pi is equals to 100 by eta into mgh by T. So applications to calculate power in various situations. If a machine gun fires n bullets per second such that mass of each bullet is m and coming out with a velocity v, then the power of machine gun is P is equals to n of half m square by T. When n bullets are fired in time t, then n is equals to n by T. So then P average is equals to half n m v square. A conveyor belt moves horizontally with a constant speed v. Gravel is falling on it at a rate of dm by dt. Then extra force required to drive the belt is F is equals to dm by dt into v. Extra power required to drive the belt is P is equals to F into V. So that is equals to dm by dt into V into V. So P equals to dm by dt into V square. Now, if pump lifts water from depth h and delivers at a rate dm by dt with a velocity v, then power delivered is equals to P into is equals to dm by dt of gh plus v square by 2, or P is equals to mgh plus half mv square by T. The car moves on a rough horizontal road with a constant speed v, then the instantaneous power of engine is P is equals to F into V. V is constant but F is equals to F. So P is equals to F into V. Here F is the frictional force on rough horizontal surface. So then P is equals to mu mg into V. Now discuss MCQs. The dot product of force and velocity is work, power, impulse, pressure. The dot product of force and velocity is power. Next, if a vehicle moves with constant speed v, against friction, power of the engine is mu mg by v, mu mg into v, mu mv by g, mu mg by v square. Here a vehicle moves with constant speed v, against friction, power of engine is mu mg into v. Thanks for watching this video.